Hello students, today we are going to discuss about differential phase shift keying or a Dpsk. It is also one of the phase shift keying method, comes under non-coherent version of Bpsk. So when we compare this Dpsk and Bpsk or Psk, there is an ambiguity of phase modulation. When we rotate the constellation points, it affects communication channel through which the signal passes. That problem is overcome by using the data to change rather than a set of the phase. So that is why we are going for differential phase shift keying. So it is also a common form of phase modulation that conveys the data by changing the phase of the carrier wave. For example, in differentially encoded Bpsk, a binary 1 may be transmitted by adding 180 degree to the current phase and a binary 0 by adding 0 degree to the current phase. Another variant of Dpsk is a symmetrical differential phase shift keying, or as Dpsk, where encoding would be plus 90 degree for 1 and minus 90 degree for 0 degree. So here we have only Dpsk. So we will discuss about Dpsk in detailed way. The modulated signal is shown here. We consider this is the modulated signal after a Dpsk waveform. Here d of t is the actual Euclidean distance of binary bit stream. B of t minus dp is 1 bit delay with time period of dp. So when we are taking the XOR function of d of t with delayed bit, which induces b of t. So this is the basic principle of Dpsk. So this is the block diagram for Dpsk transmitter. It consists of one XOR operator, 1 bit delay element and balanced modulator. So the input sequence is given to XOR operator, and here we are introducing 1 bit delay. So zeros and ones are given to XOR operation. Based upon the previous outcomes of B of t, this XOR will produce outcome. So the balanced modulator here, it is used to modulate the bit stream from the Dpsk transmitter along with the high frequency carrier signal. Here we are maintaining the frequency as constant, amplitude as constant. The only thing is we are differentially phase shifting the carrier signal. Okay, so the formula used for obtaining B of t is equal to d of t XOR of B of t minus dB. So Bpsk, carrier changes on both symbols 1 and 0. In Dpsk, carrier phase changes only on symbol 1 alone. So t is equal to 2 tb. S of t is equal to B of t into root of dp cos 2 pi f naught of t. It is similar to the previous cases. I told you only one change is allowed in Dpsk. So this is equivalent to plus or minus root 2p cos 2 pi f naught of t. So this is the block diagram of Dpsk receiver. Dpsk signal is given to synchronous detector. Here one delay is introduced, integrator, bit synchronizer, and we can obtain the demodulated signal from this side. Okay, so Dpsk signal is directly given to the synchronized detector. So synchronized detector means whatever the carrier we are using in the transmitter block, that is reproduced with help of the synchronized detector. So that is obtained with help of the delayed unit. Integrator is used to demodulate the signal based upon the detector output. So we can achieve the demodulated signal at the receiver side. So Dpsk receiver using correlator. This is the block diagram. Here Dpsk signal is given to one product multiplier. We are introducing delay element here. So one phase shift is introduced here, another phase shift is introduced here. Here one integrator is used to obtain the carrier synchronization. The switch will be closed for 0 and this will be open for open for 0 and closed for 1 condition. So the decision device is used to compare the threshold value with the outcome of this integrator. If it is greater than that value, greater than 1, then the assumed bit is considered as 1, otherwise it is considered as 0. So this is the basic principle of Dpsk receiver. So these are all the mathematical explanation. So a detector, b of t root 2p cos 2 pi f naught t plus 5 will be there. After the detector, here you have cos a cos b combination. So you expand this equation, you will get this equation like this. So fb is equal to 1 by tb and f naught is equal to n into tb. So substitute all these things in the basic equation s of t. So s of t will be equivalent to b of t into b of t minus tb. This is equal to this equation. So after integrator we have this function like this. So here due to the phase reversal, these terms get cancelled. So s naught of ktb is equal to b of ktb into b of k minus 1 into tb after substituting these elements. So whenever b of t is equal to b of t minus tb, that is delayed unit, then d of t is equal to 0, that is Euclidean distance is 0, both are plus 1 value or both are minus 1, then d of t is equivalent to 0. So b of t into b of t minus d tb is equal to 1 volt for d of t is equal to 0, and b of t is equal to b of t minus tb, then d of t is equal to 1. That is, in other words, b of t is equal to 1 volt, b of t minus tb is equal to minus 1 volt, or b of t is equal to minus 1 volt, b of t minus tb is equal to plus 1 volt for d of t is equal to 1. So we can conclude that b of t into t minus n will be equivalent to d of t is equal to 1. So the decision device which will compare the threshold value with the generated output, detector output. So p of tb minus tb will be derived when d of t is equal to 1 and it is equivalent to p of tb, then d of t is equal to 0. So this is the bandwidth formula. Bandwidth is equal to fb. An advantage of this method is no carrier synchronization is needed. Disadvantage or drawbacks are nothing but error is very high, error propagation is more, noise is more, detection maybe go wrong. So these are all the drawbacks, and probability of error is given. Here this equation is equivalent to 1 by 2 e power minus e divided by 2n naught, or in simplified way we can tell 1 by 2e minus eb by n naught. Thank you.